Uh, hey everyone. First of all, I'd like to thank you all for coming here, and especially to those who voted for my talk. Thank you for giving me this opportunity to speak at the first Hack in the Box in Singapore. So today, I'll be talking about SOHO exploitation. Yep. Today I'll be talking about SOHO router exploitation. First, I'll just describe some of the simple low-hanging fruits from web stuff to how to write exploits on IoT devices. So basically, my name is Lyon again, and I'm from Singapore. I work at a company called Vantage Point Security. Basically, I do pen testing. Most of the time, I do web stuff, and I like to hack mobile applications during work. On my free time, I like to hack SOHO routers or IoT devices, go through firmwares and stuff like that. And yeah, previously I spoke at DEFCON IoT Village, gave an ARM exploitation workshop at IoT Village, and also spoke at XCon. Yep, and so the reason why I started researching into IoT devices, it's because first I want to protect my own network. That's how it all started, researching into my own router. And also, Singapore, if you watch the news in Singapore, they want to be a smart city. There might even be smart dustbins in Singapore, like all this like ridiculous smart stuff. So it'd be cool to hack them. So I want to tell you a story. About a year ago, I attended the Colin training. Colin is like the x86 guy, right? You want to learn how to write x86 exploits, you go to his site and you learn stuff like that. So I hope to give back to the community and by providing ARM and MIPS tutorial in future. Yep, and hopefully pop as many shells as we go. So who am I? I'm a rather regular guy. I have just basic understanding of assembly and exploitation, attended some training, OSCP and stuff like that. And so most of the time I spend my, I have a double life. In the night I hack IoT, in the day I hack web and mobile. It can get quite tiring, but it's fun. Can be quite addictive. So the current state of embedded hacking is still quite kind of immature. You don't have like a methodology like OWASP and stuff like that where you can refer to. Yes, there is references online, but there isn't that much around. So it would be good to provide more information online and tutorials online, stuff like that. So the current state of IoT is still kind of bad. It's like back to the 1990s where you get all these ridiculous shells where you can pop, and there really isn't much privilege separation. It's like the vendors include these backdoors, and really it's almost like the vendors really do not care about security. So while I was pen testing for this vendor, I found this huge list of vulnerabilities, popping shells everywhere, and passwords in the web console. And so I have this list of bugs, right? And then when I look at another router, a different vendor, completely different vendor, I can repeat the exact same bugs. It's almost like different vendors using the same software. It's kind of ridiculous, right? It's like these vendors really do not care about security. And yeah, so when I want to attack IoT devices, I like to look at the attack surface first, what kind of device it is. I want to understand, is it ARM or MIPS architecture? Most typically it's Linux. And yeah, so you want to understand what are you pen testing and look at every single entry point where you can attack. So the first thing I'd like to do is to, of course, get root, right? To get the firmware, to understand what software is running on the device. One way where you can get the image is via the hardware. So what you can do is you can desolder the IC chip off the router, put it into an IC adapter, plug it into your CPU, and then you can have the firmware. So when you have the firmware, you can start researching more what libraries are on there, what services and stuff like that. So of course, that is like kind of like the last resort. There are other ways you can get firmware. You can get it online, and yeah, you can start unpacking them using SquashFS. There's quite a lot of tutorials online how you can unpack firmwares. And yeah, so once we get the firmware, we start to dig for shells, right? You want to get zero-day vulnerabilities and stuff like that. So we're going to identify what services are on there, HTTP service, Telnet, what libraries are they using, and really just understand every single entry points, they're UPnP enabled and stuff like that. So it really does not take long before you start popping shells. So at Vantage Point, I work with a few IoT vendors. And most commonly, the HTTP and Telnet services are they're always full of bugs. You can really find lots of stack overflows, and it's almost every string was insecurely handled. If you do a grep in IDA Pro, you can see like they use string copy, string compare, and really it's just very poor programming. And most commonly, you will find restricted shells where you can pipe it, have a backdoor, or even there was one router where you can dump the memory. Why do you want to give someone to dump the memory? I don't understand. So, of course, there's lots of bugs where we can find. And so from file upload to directory traversal, to command injections, or even a stack overflow via UPnP, that's even possible. So in IoT, we want remote authenticated bugs. Why do we want that? Because we want to attack routers, not just one router, we want to attack in large scale. So usually these routers are open to the WAN. Most of it I see, some of them are open to the WAN by default. So when they the ISP ship the router to you, to your house, if you have a static IP address, you'll be open to WAN by default, and if you're not a technical guy, probably could be hacked. And probably the hackers would like to hack the Telnet and HTTP service first because that's the easiest and that's where the bugs are. And most commonly, these services are run as root. So once you are able to pop shell, you'll be root, and yeah. So why are there so many stack overflows in these softwares? So typically, what I notice is these developers take this open source software off the shelf, like micro HTTPD, and then they customize it. And when you customize it and it's coded in C and C or C++, they have no knowledge over security, and that's why, of course, you have your stack overflows. And I'm not sure about you guys. I do not know a lot of developers who are very strong in C or C++. Most of them code in Java, ASP.NET, PHP. Not much of them code in C or C++ anymore, right? Yep, and yeah, that's the reason why we can find so many stack overflows. So typically, I find bugs like this. You can get stack overflow in the HTTP request, in the Telnet. Like for example, this one, when we change the password, you can, from a user, you can change the password and you can overflow the stack. There are other ways where you could overflow is also via the UPnP request. That's also possible. So today I'll be talking about the Zone. I'll be talking about some 0 days discovered in Zone. Who is Zone? They are actually a company based in the US, California. You do not really buy them off the shelf. Usually ISPs, service providers, buy these routers in bulk, and also enterprise networks. As you can see from the screenshot, they are deployed in data centers. So the reason why I look at Zone was because my ISP forced me to use this router. and so when they gave me this router, I was like, whoa, what is this Zone router? And I have to pay and rent this router. When I wanted, the only way I could do it is to set it on bridge mode if I want to use my own router. So I'm a security guy, right? I don't want to be hacked, right? So I called up the Zone tech support. Hi, can I get the admin password, please? I would like to protect myself. No? Okay. So, so I was like, all right, maybe I'll try to do something about it. So I started digging, and yeah, that's where this research started. And if you look at Zone, sorry, can't really see the chart, the names, but there's actually a lot of ISPs that uses this router, and it's all over the world. It's not just Singapore, in the US or in some other countries. Can't really remember the countries, but yeah. So when we attack the router, most commonly we can find cross-site scripting. It's common. So one of the first vector we could use is stock cross-site scripting. Since the tech support didn't want to give me the password, I could probably do a stock cross-site scripting, attack the technical support. Say, hey, I have some problem with my router, and I attach beef in the payload. And when the tech support helps you, you kind of can exploit him, and yeah, you get the idea. So that is cool, but this is Singapore, and it's illegal. I don't want to go to jail for attacking the tech support. So I started digging, right? Say, oh, cross-site scripting was so easy to find, right? So most of you guys should be able to find it. So I started looking, and I realized not only on Zone, in all the some of the routers or IoT devices, they do not have proper access control. So all these functions, you can actually do a direct object reference. So what does this mean? So they only use JavaScript to prevent the user from accessing the administrative functions. So actually, as a user, you can actually access all the admin functionalities. And so if you look at the source code here, if user equals to admin, they will give you the admin menu. So I do not have the full list of admin functions, right? Because I was a user. So I put it through burp, and I, of course, modify the response for all responses. If it's user, if it's admin, change it to user, then my admin menu will appear. Yeah. So this is great, right? I know that I have all the admin functionalities. I can finally secure myself, but I still feel very afraid. It's like, if it's so easy to find bugs like that, there must be more bugs, right? So then I want the admin password, right? I just don't want the function. I want to change the password. I don't want the tech support to have anything in my router. I want them hands off. So commonly, none of it only in the Zone router. In other routers that I discovered in Singapore, where I bought off the shelf, the backup settings would contain the admin credentials or user credentials, all the user credentials, base 64 encoded. And some of them are even unauthenticated. So you don't need to be a user. You can actually just download the backup file and have the passwords. Yep, so this is a sample HTTP response. If you see, you can get the admin password, the support password, and the user password, all base 64 encoded. Yep, so I called up and I sent an email to Zone. They fixed the bug, and they fixed the previous bug. They kind of removed the passwords from the backup file. So I was like, I think there is still some kind of vulnerability over here with the backup file. So I thought of another idea was to patch the admin password via the upload settings file. So instead of downloading the settings file now, I upload my own settings file. So I don't even need the admin password. I can actually patch all the user's password via the configuration file. And this can be also used, this is a common technique that I realized I can replicate across the other IoT devices. So yeah, through this way you can kind of privilege escalate again. And yeah, so now I got the admin password, right? I still want to find more bugs. The main goal we want is to get root, right? So when we get root, we can start putting our GDB server inside, start fuzzing it, start getting Stack Overflows and stuff like that. So of course, I guess most of you know you can just, in a restricted shell, you can just pipe it and you can execute commands. So if you see here, you turn it in, you use the download -sw, you just pipe it, and then you can execute shell commands. So now I finally got root, right? But and I start downloading all the firmware and everything, taking everything out, start analyzing them. Yeah, and of course I want more zero-day vulnerabilities, right? So I put the libraries in either pro, and for me personally, I first thing I want shell, right? So why not let's search for a shell? So I searched for shell, and of course there's a list of stuff that came out that says run shell command with timeout, and so I can identify quickly which commands in the web console runs a shell command. And as you can see, if I can inject stuff inside and start getting remote command execution. So while browsing through, of course, this is a common one found in all routers. Is through the ping or trace route functionality. They take the user input and they straight away run the command, and your shell command will just run. The problem with doing black box pen tests is because when you do this, in the HTTP response, they might not show you any response, right? But because I have the libraries, I know exactly where is the vulnerability, and I know it's definitely vulnerable. I can start attacking it, and because I have root access, I know for sure that I can run certain command, write certain file to the writable directory, and I know that this is a zero-day vulnerability. So for this particular case, the exploit can be it's a very simple one. In the ping functionality, you just pipe it, you download a shell file into the temporary directory, which is commonly one of the writable directories on the router. Most commonly in routers, the directory is not writable. It's only temp directory and certain directories you can write to. So most commonly, I like to write to the temp directory, change the permissions to executable, and then run it, and then we pop off shell. So yes, all these are like the low-hanging fruits. It's kind of fun, cute. But we want Stack Overflows, right? We want to learn how to write exploits and stuff like that. So for this particular case, I found a Stack Overflow in 2 locations. It's in the get HTTP request and in the body of the post request. For fuzzing Stack Overflows, what I most commonly find in certain routers, the .html might not be vulnerable. It's good to fuzz different extensions. So for one specific router, I found that only the .cgi can be overflowed, but the other extensions is not. So it's good to fuzz all different extensions and different parameters and stuff like that. So after fuzzing, and then we get the in the GDB server, this is what I get as a response, which is what we want, is to have 414141 in the program counter. So for you x86 guys who do not know ARM or MIPS, what is a program counter? A program counter is basically your instruction pointer in x86, where it controls the flow of the program. So if you have control over the program counter, you basically can point the program to another location, which can be your location of your shellcode. So once you control the flow of program, you win. And the good thing for this vulnerability is that I have control over most of the registers, and I can start writing my exploit. With these registers, if I control it, I can start putting my rock gadgets and make use of them. So with these registers, it's really helpful in writing exploits. So before you write exploits, I would most recommend we want to understand the environment. If there's ASLR, if the stack is executable, just imagine if you start trying to write your exploit for 3 months, for a few months, and then you realize actually your stack is not executable. Then you have to you kind of waste your time in trying to use this technique. You have to look at other avenues. So yeah, for this particular case, and for a lot of cases, I don't know why the stack is executable. I think it's when you compile it, you have to manually set the binary is executable. So I'm not sure why do these vendors set it executable. Maybe it's got to do with something with hardware. I'm not sure. Yeah. So when writing these exploits, I realized there's a few documentation online that of this problem, cache incoherency. So what does cache incoherency means? When you pass your shellcode over, there is the instruction cache and data cache. So there might be instructions in your instruction cache. No, there might be, sorry, in the program, before you send your exploit, there might already be instructions in the instruction cache. So when you send your exploit over, the instruction cache will always take precedence over the data cache. So your exploit will never work properly because of old instructions in the instruction cache. So what we need to do is we need to flush the instruction cache. So for flushing the instruction cache, in particular to MIPS, it's quite known online if you read somewhere that you can actually call the sleep function. This sleep function, or any blocking function such as sleep, what does this sleep function do? This sleep function actually switch context to give CPU cycles. And when they do this, when they call blocking function, it actually will flush the instruction cache automatically. So how do we call the sleep function? So we need to use rob gadgets. What is rob gadgets? Rob gadgets is return-oriented programming. Exactly what rob gadgets is basically instructions stored in the binaries or libraries of the HTTP binary or libc. So these instructions are stored in this. When you open up a library, for example, libc, in IDLEPRO, you have a list of instructions, right? So basically, when you call a certain address in the binary, you're actually calling the instruction. So rob gadget is actually making use of these instructions to run instructions that we need. So the first one is to set up a value 1 in A0, which means actually telling the program to sleep for about 1 millisecond or something like that. You don't want the program to sleep forever, right? You want to go back and run your shellcode, so you need to set it sleep. And the second rob gadget is, of course, to call the sleep function. So once you call the sleep function, the instruction cache executes. The instruction cache flushes. And next, we can jump back to the stack and execute our shellcode. So to do this, we need 2 more rob gadgets. One is to copy the address of the stack, because we want to know where we want to jump back. And the second one is to, of course, jump to the exact stack address to execute the shellcode. Yep. So this actually, because you need to call a sleep function, you need to call rob gadgets. So this results in actually kind of bypassing ASLR, which is a common problem. Yep. Most commonly, I like to use Craig Hefner's tool. If you wrote MIPS exploit before, I'm sure you know this tool. It works very well for me to get rob gadgets. Yep. So I'm very excited to pop my shell, right? I got my rob gadgets ready. Yes. Then I want to find the easiest way. My very first time, I want to find the easiest way to pop shell. I don't want to write my own shell code, right? So I use Metasploit. I generate the shell code. I was so excited. Then I used MSF encoder. There was an encoder, and then I encode the shell code. And then okay, let's go. I was like really excited. And then when I ran it, I was like, oh, no shell. I was like, oh damn it. Then I traced through GDB. When I traced through GDB, I went line by line, instruction by instruction, and I saw the shellcode decoded correctly. And I was like, okay, the shellcode decoded correctly. Why aren't I popping shell? And the second thing that I noticed was when I go through GDB, the shell popped. Without GDB, the shell didn't pop. I was like banging my head against the wall. I was like, oh my god, calling my my colleagues say, do you know what's happening? I have no idea what's happening. Um, so I started analyzing the MSF encoder, and I really didn't know what was going on. I even see like system calls, which is not required. So I thought maybe if there isn't a lot of bad characters in my shellcode, I could just encode the bad characters and write my own MSF encoder, and maybe it will work. So I thought of giving that a shot. So when I look at the shellcode, turns out there's only 2 bad characters, which is great for me. There's only 2, and I can just manually encode them and write an MSF encoder to just encode these 2 characters. This is just a simplified version of the encoder. Basically, you are just XOR, using an XOR encoder to XOR the bad characters, to decode it on the fly. And yeah, so now I got my MSF MIPS encoder. I got my ROP gadgets. I got my shellcode. I'm again excited to run it. And when I ran it, finally the shell popped. I was so excited, but it died instantly. I was like, oh my god. I was like, what's happening, right? I popped my shell, I traced through the code, I don't understand what's happening. So for like a whole week, I was every day midnight, I was like tracing through the code, trying to find out what's happening. And so what I realized is that actually most of these routers, they have this service that constantly monitors all these critical services. So when the critical service is not working correctly, functioning properly, for example, if you browse to 192.168.1.1, you don't see the admin console, then it would kill it and respawn a new process. So that's the reason why the shell popped and died instantly. So I thought, I was reading online, and so I was looking at how all these processes work, and I was thinking maybe we can try and fork the shellcode. So yeah, so the forking the shellcode actually worked. So what do you mean by forking the shellcode? Meaning you actually spawn a new process, a completely separate process from the HTTP process. So even if the HTTP process dies, your shellcode process will still work. And you can spawn as many shellcode if you want for these instances if you use this method. So to recap again, we have the in MIPS exploit writing for cache incurrency, we use the sleep function. For ASLR, technically you just use the ROP gadget already, so you kind of bypassed it. For bad characters, you can actually write your own MIPS encoder for simple ones. And for the auto respawn process monitoring, you can actually fork the shellcode. All right, okay, enough of the slides. Let's try and see if we can get shell. So first, I'd like to demonstrate to you how we can get the 4141 trigger the exploit. So over here on the client machine, I'll run GDB. So over here on this is actually the zone router. I have a shell prompt in the zone router. I'll run the GDB server. So I've run the GDB server to run on port 1234. So 1 second. So over here, let's refresh it. So when you refresh it, they actually spawn a new HTTP process for you. So now that over here in this line, you can see that the HTTP process is running. Can you guys see it? Yep. And so I get the process ID. So now on the client side, on my GDB, I'll attach to the GDB server. So over here, I'm attaching to the HTTP process. So now what's happening here is actually we are hooked into the HTTP process remotely. Why am I using GDB? Before that, I used IDLEPRO, and it didn't work very well for me. It always crashes, and I find GDB to be the most stable one. Although GDB is painful to use, but it's the most stable one. I highly recommend just using this method. Even if you run it in QEMU, your HTTP binary, and attached to IDLEPRO, it's still there's some environment differences. So I find that by doing this method, using GDB server, is the best way for writing exploits. So now I'm hooked on it. Let's continue. So I wrote a Python script, a simple Python script, just sending 7,000 A's. And in the post command, I included inside. As you can see here, I'm sending it over. So I shall run the exploit now. So it's sent successfully, and 4 So which is what I showed previously, and you actually have control over the program counter. Yeah, this is great, right? But you guys want to see shells, right? So so let's see that. Yeah. Okay. So first, I'll go through the exploit that I wrote, but because of how the ROP gadgets communicate with each other, it's a little bit complex. I apologize in advance if you don't understand the script, but I'll try my best. So we're sending to the host the gateway 192.168.1.1. Over here is the S1 register. I set it to the sleep function address, which we'll be using later. S3 is the second ROP gadget. And return address is the first ROP gadget. RA is actually the return address of the program counter, which you will use in the exploit. And why we pointing to the first ROP gadget? Because the first ROP gadget is the first instruction you want to run, which I previously explained. And yeah, lots of stuff. There's the third ROP gadget and the fourth ROP gadget, which I appended all to the shellcode. And over here, SC underscore encode is the encoder to encode the back characters, the encoder that I wrote myself. And yep, so let's go all the way down. Yep. So over here, you can see that I send the get command, send the buffer, which is just like NOPs, and the registers that I can control, the S0 to S7, RA, which is also your PC, and then the shellcode, and then this is the exploit. So for this exploit, I actually hard-coded it to listen on port 12347. Don't ask me why I use 12347. And shell. So who am I? Root. And yeah, we got the password. So now I finally got like few zero-day vulnerabilities, and then what I realized was that actually when this ISP gave me this router, the how did the architecture in the back end is actually, there's a few VLANs. So basically, if I'm a subscriber and you're a subscriber, I can actually talk to your router. So you can start attacking the internal VLANs and start attacking maybe even the technical support. So it is quite scary how this specific service provider planned their architecture. And so just to recap on how the exploit works, when we use the fork shellcode, it enables the shellcode to be, the exploit to be very stable. It will, you can even spawn 4 or 5 shells at one time, it's no problem. So just to give a little bit more information on how to write exploits in ARM. So in ARM, you also have the cache incurrency, but I found different methods to actually kind of like overcome the cache incurrency problem. Just to recap again, cache incurrency is where instructions stored in the instruction cache will always execute instead of data cache. So commonly in your exploit, when you have bad characters, and when you write an encoder, which is considered self-modifying code, you actually will cause in-cache incurrency. And yeah, so the solution I found was this. So basically, you just encode and decode only the data portion of shellcode. Most commonly in your shellcode, there is the data portion. What do I mean by data portion? The data portion is your IP address, the port number where you connect back. And because all these always have null bytes, that's where always the back characters is. And when you write your shellcode, actually, you can actually use different instructions to bypass any back characters. So most commonly, I found this method works the best, is to just encode the data portion only, and don't encode the instructions. Yeah, so how does this actually work? So when you pass the shellcode over, the decoder will actually decode just the data portion, which is encoded. You encode it in advance. And when it's decoded, you have a decoded data. So when it goes down, when the shellcode executes, it actually reads the data from the data cache. It doesn't read the data from the instruction cache. Makes sense, right? Because it's data. And that's why it kind of bypasses the cache incurrency. Your instructions will run perfectly fine. Yeah. And so I wrote an ARM encoder for this purpose. It's still in the alpha stage, but I'd like to add more stuff like for MIPS and stuff so that people can easily write exploits. There's still a lot of work to be done. If you want to help me or you contribute, you can let me know. I have a lot of ideas of what to do, but it takes time because this only started 1 year ago. So yeah, in IoT, there's really a lot to protect. Basically, we have the web stuff, the network stuff, wireless, host hardening. There's really so many things that you need to do to protect an IoT device, and maybe that's why we can easily find zero-day exploits on these IoT devices. Yep, so these two are the awesome references that I have. Craig Hefner, if you guys do a lot of router exploitation, you know that he, in his blog, has a lot of information on how to hack routers. And Jonathan Style one is more for writing ARM shellcode. I find it really useful in learning how to write ARM shellcode. If you want to learn, this is a good reference. And you can contact me through this information, follow me on Twitter. And also, I'd like to thank these people for helping in my research, giving me ideas on how avenues that what this research can do. It was actually just beginning with a router, and then people start telling me, dude, you can hack the whole of Singapore, you can start hacking stuff and do an analysis and stuff like that, and it was really helpful. And also technically and presentation, and these people just, thanks to them, if not, this would not be possible. Yep, thank you. Is there any questions?